Hello students, today's class is on non-parametric statistical tests. Non-parametric tests for statistical significance does not assume anything about the underlying distribution of data. You may have finished this session on parametric tests, right? In case of parametric tests, there is an assumption that data follows a normal distribution. But in case of non-parametric test, there is no assumption about underlying distribution of data. In other words, I will tell you, non-parametric test means that you know that population data does not follow a normal distribution. Population data is not normally distributed. Now we can go through differences between parametric and non-parametric tests for statistical significance. Parametric tests have an assumption about the population parameters. For example, mean or standard deviation. There is an assumption about population parameter. What is the assumption? Parametric test assumes that data is normally distributed in the population. But non-parametric tests are applied when data does not follow a normal distribution, or when data is not normally distributed, we can use non-parametric tests. Okay, now we can go through some non-parametric tests. Okay. On the left side are the name of the parametric test and the right side are the non-parametric alternatives. So, left side those tests that can be applied when data is normally distributed. That right side non-parametric alternative tests are applied when data is not normally distributed. You look at left side paired t-test. You know that paired t-test is applied when you are having data before and after treatment, or data from same participants at two different times. Okay, paired t-test can be applied when data is normally distributed. If data is not normally distributed, you can apply signed test. Signed test is a non-parametric test. Paired t-test can be applied when the data are paired or before and after data are there. Okay. Another non-parametric alternative test is Wilcoxon Signed rank test. That is an alternative of paired t-test. So two alternative tests are there for paired t-test. One is signed test, second is Wilcoxon Signed rank test. What is the alternative for independent sample t-test? Independent sample t-test is otherwise known as unpaired t-test. Okay. Independent sample t-test is a parametric test. When data is normally distributed, we can apply independent sample t-test. But when data is not normally distributed, we can apply Mann Whitney U test. Mann Whitney U test is the non-parametric alternative of independent sample t-test. Okay. One-way ANOVA test can be applied when there are multiple groups are there and numerical data of multiple groups are compared. When data is normally distributed, we can apply one-way ANOVA test, right? But when data is not normally distributed, the observations in multiple groups, more than two groups, can be compared using Kruskal Wallis test. So Kruskal Wallis test is the non-parametric alternative of one-way ANOVA test. Next, Pearson correlation test. It is used for the linear relationship between two continuous variables, right? When data is not normally distributed, we can apply Spearman's correlation test. Okay. These are the various non-parametric tests for statistical significance: Signed test, Wilcoxon Signed rank test, Mann Whitney U test, Kruskal Wallis test, Spearman correlation analysis, and chi-square test for categorical variable. Chi-square test will be covered in another session. So we will be going through Signed test, Wilcoxon Signed rank test, Mann Whitney U test, Kruskal Wallis test, Spearman correlation analysis. Signed test is the non-parametric alternative of paired t-test. Wilcoxon Signed rank test is non-parametric alternative of paired t-test. Mann Whitney U test is the non-parametric alternative of independent samples t-test. Kruskal Wallis test is the non-parametric alternative of one-way ANOVA test. Spearman correlation analysis is non-parametric alternative of Pearson correlation. Okay, so please keep in mind. Now we will go through Signed test. Okay, there are some assumptions for Signed test. Signed test is non-parametric alternative for paired t-test. What are the assumptions? Dependent variable should be measured on continuous scale. Continuous scale can be interval or ratio scale, or ordinal level also. So dependent variable can be either continuous scale, which are interval and ratio scale, or ordinal scale. Ordinal scale is ordinal categorical. Independent variable should consist of two categorical or related groups or matched pairs, like values before and after an experiment or before and after a treatment. Okay, so two categorical independent variable is there. One is before treatment, other is after treatment. Dependent variable can be continuous or ordinal. Continuous can be ratio or interval scale. Ordinal is ordinal categorical. Then what is the other assumption? Observation does not follow a normal distribution. Now we can see how it is done. So arrange the observation of paired data. Paired data means data of same person at two different points in time as two columns. Set 1 and set 2 are observation of same patients at two different times. Calculate the difference between the observation as the third column. Look, set 1 minus set 2. That is a difference between observations as a third column. Then check for the sign of the difference. Okay, 443 minus 57 is 386. That is plus sign. Second one, 421 minus 352. That is also 69 plus sign. Third one, please check. 436 minus 587. So the difference is minus 151. So sign is minus. Next also minus, right? 376 minus 415. It is minus 39. So sign is minus. Understood? So check for the sign of the difference. You have to note the signs. Plus sign, minus, minus. Not applicable. Why? The difference is 0. Then also minus sign, minus sign, minus sign, plus sign. Like that you have to give the sign. count the number of positive signs and negative signs. Okay, there are 4 positives. 1, 2, 3, 4. 4 positive signs and 12 negative signs. 12 negative signs seems a lot. Okay, so we can say the difference is towards in a way 12 negative signs are there. So set 1 is smaller than set 2, or set 2 is having a higher value than set 1. We can say that because 12 times negative sign is there. That means set 2 is higher than set 1. But we cannot say that the set 2 is significantly higher than set 1 or not. For that we have to apply sign test. Okay, how to do sign test? We can use SPSS to do sign test. How? You click on Analyze, Non-Parametric Test, Legacy Dialogues, and look for two related samples before and after treatment. In this example, we will see fasting blood sugar before treatment and fasting blood sugar after treatment. We can find out if the sign test shows a significant difference or not. Okay. So now here FBS-BT is fasting blood sugar before treatment and FBS-AT is fasting blood sugar after treatment. Okay. You select variable 1 as FBS-BT, variable 2 as FBS-AT. Please select the test type as sign. Okay, sign test we selected. Then you click OK. Then it will be showing how many negative differences, how many positive differences. So it is showing that FBS-AT minus FBS-BT 31 negative differences. That means FBS-AT is less than FBS-BT 31 times. Okay, 8 positive differences. That means FBS-AT is more than FBS-BT. Ties 1 time. That means FBS-AT value is exactly same like FBS-BT value. So 31 times negative difference, 8 times positive difference. But how to know if the difference is statistically significant or not? Okay, look at the test statistics. Asymptotic significance value shows that it is 0.000. That means it is less than 0.01. Okay, so the difference is statistically significant. Asymptotic significance value is less than 0.01. So the difference is statistically significant. So we can say that negative differences are more, right? That means FBS-AT is significantly lower than FBS-BT. So why? 31 times negative differences are there. So FBS-AT is significantly lower than FBS-BT. That is an interpretation. Okay, now we can go to Wilcoxon Signed rank test. Okay, that is also a non-parametric alternative of paired t-test. Okay, so dependent variable should be measured on continuous or ordinal level. Dependent variable should be continuous level or ordinal level. Okay, continuous can be interval or ratio. Independent variable should consist of two categorical variable, two categories, related groups or matched pairs. So before and after treatment, or before and after training, or before and after some experiment. Okay, so matched pairs or related groups. And you know, it is a non-parametric test, right? So observations does not follow a normal distribution. Okay, please keep in mind. Now we can go through the requirements for doing Wilcoxon Signed rank test. These are the assumptions. Data must be matched or paired. Look at this example. Same group of people. What are the values before treatment and what are the values after treatment? So before treatment values should be written in column 1 and after treatment values should be kept in column 2. Dependent variable must be continuous. Continuous variable means it should be either interval or ratio scale or ordinal. Ordinal also can be. Now take the difference. Okay. After treatment value minus before treatment value. Take the difference. Okay. That's after treatment is 4. Before treatment is 2.5. 4 minus 2.5 means 1.5. 5.6 minus 3.5 means 2.1. 3.2 minus 2.9 means 0.3. Okay. Take the difference. Now place the differences in order. Okay. You arrange the differences in order. The lowest on top and the highest difference at bottom. So lowest difference was 0.1 and the highest difference was 12.4. So you have to arrange the differences in order. Then you give the ranking 1, 2, 3, 4 like that. When you arrange the differences in order, please ignore the sign. Okay, that's a concept. Then after that, okay, make a third column and note the sign of the difference. So first you find out the differences, then you rank the differences, then you give the sign for the difference, sign for the rank. So 0.1 was actually minus 0.1. So sign is minus. 0.2 was minus sign. 0.3 was plus sign. 0.6 was minus sign. Like that you have to give the sign. So we got Wilcoxon signed rank. Okay, signed rank. Now you add up all the negative ranks. Okay, that means negative signed ranks are 1, 2, 4. Yeah, 1, 2 and 4. You add up. That is Wilcoxon's negative rank. That is 1 plus 2 plus 4. That is 7. Now you add all the plus signed rank. So plus signed ranks are 3, 5, 6, 7, 8, 9, 10, 11, 12. You have to add all that. So 3 plus 5. 5 is actually 5.5 you have to put because 5 and 6 are same value, right? So you have to put 5.5 plus 5.5 plus 7 is also plus sign. 8 is also plus sign. 9 is also plus sign. 10 is also plus sign. 11 is also plus sign. 12 is also plus sign. So in between 5 and 6 were having same rank, same value. So we have to give the rank 5.5 and 5.5. So like that you add it. So all positive ranks total is 71. All negative rank total is 7. So that means positive is more, right? Positive is more. The difference is more positive. But we have to use SPSS to check if the difference is statistically significant or not. Okay, how to do Wilcoxon Signed rank test, you click on Analyze, Non-Parametric Test and the related samples. You have to click on that. So now you select the two variable. You click on field and select the two variable, fasting blood sugar before treatment and a fasting blood sugar after treatment. Okay, then you got this one. Related samples, Wilcoxon Signed rank test. It is statistically significant. That means the difference is statistically significant. So reject the null hypothesis. Okay, so the null hypothesis was that median of difference between fasting blood sugar before treatment and fasting blood sugar after treatment equals 0. Computer is asking us to reject the null hypothesis. Why? Significance value is less than 0.05. Now we can go to the next test, that is Mann Whitney U test. Okay, it is a non-parametric alternative for independent samples t-test. So what is happening? What are the assumptions here? Dependent variables should be measured on continuous scale or ordinal scale. Continuous means it can be interval or ratio scale. And ordinal scale means it's categorical ordinal. Independent variables should consist of two categories. They are unrelated groups, not like a previous one. Previous two tests, sign test and Wilcoxon Signed rank test, were related groups. Here they are unrelated groups or independent groups, like gender, male and female, both are independent. Observations in different categories do not follow a normal distribution. So if you are taking the value among males and value among females, they are not normally distributed. That's why we are choosing Mann Whitney U test. So there are two samples, placebo and a new drug. Okay, what are the values of placebo group? 7, 5, 6, 4 and 12. And the values of new drug group is 3, 6, 4, 2, 1. Now we have to arrange in order. Okay, 1, 2, 3 are new drug values. 4, no? 4 is there for new drug, 4 is there for placebo also. 5 is there only for placebo group. 6 is there for new drug, 6 is there for placebo group also. 7 and 12 are there for placebo. So you have to arrange from smallest value to largest value among placebo, among new drug. Then you have to put the ranks. New drug is a 1, right? So rank is 1. 2 is also new drug, rank is 2. 3 is also new drug, that is rank is 3. 4 is there for new drug and placebo. So 4 and the 5th rank is there, right? 4th rank is there and the 5th rank is there. So we have to take average of that. That's why 4.5 and 4.5. So fifth value 5 is for placebo. So that's rank is 6. Then 7th and 8th rank will be for the value 6, that is placebo and a new drug. So you have to take average of that. So 7.5, 7.5. Then 9th rank is for the value 7. 10th rank is for the value 12. So you have to arrange the ranks. Okay. Now what is the next step? Okay. Test statistics for Mann Whitney U test. Okay. Test statistics for Mann Whitney U test is U. Okay. And is the smaller of U1 and U2 defined below. Okay. U1 you have to calculate and U2 you have to calculate. Then you take the smaller one, that is the Mann Whitney U value. How to calculate U1? U1 is equal to N1, okay, multiplied by N2 plus N1 multiplied by N1 plus 1 divided by 2 minus R1. That is a U value for group 1. That is U1. U1 is the U value for group 1. Okay. R1 is the sum of the ranks for group 1. Then U2 is equal to N1 multiplied by N2 plus N2 multiplied by N2 plus 1 divided by 2 minus R2. R2 is the sum of ranks for group 2. Okay, then U1 you have to calculate. N1 multiplied by N2, right? 5 multiplied by 5. Both are having same number, right? 5 multiplied by 5 plus 5 multiplied by 6 divided by 2 minus 37. What is the 37? Sum of the rank of group 1 is 37. Okay. U2 is 5 multiplied by 5 plus 5 multiplied by 6 divided by 2 minus 18. 18 is the sum of the rank for group 2. So you got 22. So 3 and 22 you got. Okay. Now we can see the steps in SPSS. What are the steps? You have to click on Analyze, Non-Parametric Test and click on Independent Samples. When you click Independent Samples, it will show a box for Non-Parametric Test, 2 or more independent samples. Select the field. Okay, field, we are selecting systolic blood pressure and groups as gender, because 2 independent groups, right? So it should be gender. Gender is having 2 independent groups, male and female. Now you click Run. Okay, so what is the finding? Okay, so finding shows that significance value is 0.492 and retain the null hypothesis. Why computer is asking to retain the null hypothesis? Because significance value is more than 0.05. So there is no significant difference between systolic blood pressure values among males and systolic blood pressure values among females. So there is no significant difference, right? So computer is asking to retain the null hypothesis. Now we can go through the assumptions for Kruskal Wallis test. Kruskal Wallis test is the non-parametric alternative for one-way ANOVA test. Okay, what are the assumptions? Dependent variables should be measured on continuous scale or ordinal scale. Continuous can be interval scale, ratio scale. Ordinal is ordinal categorical. Independent variables should consist of more than 2 categorical or unrelated groups or independent categories. For example, ethnic groups in Malaysia like Malay, Chinese, Indian and others. Okay, those are independent categories, more than 2 independent categories. Observations in different categories do not follow a normal distribution. These are the assumptions for Kruskal Wallis test, which is a non-parametric alternative for one-way ANOVA test. Now look at the sample question. A shoe company wants to know if 3 groups of workers have different salaries. are the salaries of three different categories are significantly different or not. Women, men and minorities. These are the three categories. Salaries of women are given 23,000, 41,000, 54,000, 66,000 and 90,000. These are the salaries of 5 women. Salaries of 5 men are given 45,000, 55,000, 60,000, 70,000 and 72,000. Then salaries of 5 people from minority groups are given 20,000, 30,000, 34,000, 40,000 and 44,000. First step of Kruskal Wallis test, we have to sort the data of all groups or samples into ascending order in one combined set. Lowest salary is 20,000 and the highest salary is 90,000. So we have to arrange the salaries in ascending order: 20,000, 23, 30, 34, 40, 41, 44, 45, 54, 55, 60, 66, 70, 72 and 90,000 in ascending order we have to write. Now next step is assign ranks to the sorted data points. As first step, we have arranged the salaries in ascending order from lowest to highest, right? Now we have to give ranks for that. Lowest you give rank 1 and highest you give rank 15. So 1, 2, 3, 4 up to 15. If any of the values are same for two people, so you have to give average rank. So if fourth observation and fifth observation are same, so you give 4.5 rank for the fourth observation and 4.5 rank for the fifth observation. So like that you have to give. Then add up the different ranks for each group. So there are three groups are there, or three categories are there, right? Women, men and minorities. So you add up the different ranks. So 23 for women, 5 women are there. So their observations are 23,000, 41,000, 54,000, 66,000 and 90,000. So you find out 23,000 is rank number 2. 41,000 is rank number 6, 54,000 is rank number 9, 66,000 is rank number 12 and 90,000 rank number 15. So you add up all the ranks for women. Then for men also 45,000, 55,000, 60,000, 70,000, 72,000, right? 45,000 is rank number 8, 55,000 is rank number 10, 60,000 rank number 11, 70,000 rank number 13, 72,000 rank number 14. So you please add up all the ranks for men. Then you add up all the ranks for minorities also. So for women total rank is 44. For men total add up rank is 56. Minorities total added up rank is 20. Understand? Then you have to calculate H statistics. H statistics is the Kruskal Wallis H. Kruskal Wallis H statistics. So this is a formula for that. 12 divided by n multiplied by n plus 1. Okay. Then sum of T divided by n. What is T? You know, sum of ranks in the J sample divided by nj, that is size of the J sample. So in this case 12 divided by n is a 15, that is 5 women, 5 men, 5 minority. Total number is 15. So 5 plus 5 plus 5 is 15, right? So n is equal to 15. 15 multiplied by 15 plus 1. So that's n multiplied by n plus 1. Sum of T divided by n. T is the sum of rank of women squared divided by total number of women plus sum of rank of men squared divided by total number of men plus sum of rank of minorities squared divided by total number of minority minus 3 multiplied by n plus 1. 3 multiplied by 15 plus 1. So you have to calculate according to this if you are doing manually. So its statistics is 6.72. You have to check if its statistics is statistically significant, right? So in that case you have to use SPSS software. Okay. So then find the critical chi-square value with a C minus 1 degree of freedom. C is the number of categories. So here 3 categories are there, right? 3 minus 1 degree of freedom is there. And alpha level of 0.05. Critical chi-square value is 5.9915. So you have to check whatever H value you got is higher than the critical chi-square value for C minus 1 degree of freedom. If critical chi-square value is less than H statistics, reject the null hypothesis. Okay, if chi-square value is not less than H statistics, okay, there is not enough evidence to suggest that medians are unequal. In this case, 5.9915 is a critical chi-square value, right? Is less than 6.72. 6.72 is the H value that we got. So 6.72 is higher than the critical chi-square value. So you can reject the null hypothesis. So we can say that salaries among men, women and minority group are significantly different. Another one. Yeah, we can see how to do Kruskal Wallis test in SPSS. Analyze non-parametric test, independent samples. You have to click independent sample. For Mann Whitney U test also you selected independent sample. But for Mann Whitney U test only 2 categories are there. Here for Kruskal Wallis test more than 2 independent categories are there. So you have to select systolic blood pressure and ethnicity as the group. Ethnicity are having 4 categories: Malay, Chinese, Indian and others. So you select ethnicity as group. Test field you select systolic blood pressure. Now you click run. Okay, distribution of systolic blood pressure is the same across categories of ethnicity. That is the null hypothesis. There is no difference. Or the distribution of systolic blood pressure is the same across categories of ethnicity. What test is applied to prove or disprove the null hypothesis? Independent samples, Kruskal Wallis test. And the significance value is 0.140. It is more than 0.05. So retain the null hypothesis. We cannot reject the null hypothesis. We have to retain the null hypothesis. Now we can go to the next one, is Spearman's correlation test. Okay, what are the assumptions for non-parametric test, Spearman correlation test? Okay, Spearman's correlation test is a non-parametric alternative for Pearson correlation test. Pearson correlation test is parametric. Okay. Spearman correlation test is non-parametric alternative for Pearson correlation test. Both dependent and independent variables should be measured on continuous level or continuous scale like interval or ratio scale. Observation in any one of the variable. So variable 1 is there, variable 2 is there. Variable 1 is the independent variable, variable 2 is the dependent variable. Any of these two is not following normal distribution. If any of the two variable is not normally distributed, then you have to go for Spearman's correlation test. Okay, so here the observation is that, example is that scores of 9 students in physics and maths are given. Okay, physics marks of 9 students are 35, 23, 47, 17, 10, 43, 9, 6 and 28. Mathematics mark of the same students are given. 30, 33, 45, 23, 8, 49, 12, 4, 31. Compute the students' ranks in the two subjects and calculate Spearman rank correlation. Spearman's correlation test is otherwise known as Spearman rank correlation. How to do that? Okay, so first physics marks are given, then maths marks are given. Okay, physics mark we have to give the ranking. Find the ranks for each individual subject. Okay. We can use Excel rank function to get the ranks. Okay. Find the ranks. If you want to rank by hand, order the scores from greatest to smallest. And then assign the rank 1 to the highest score and 2 to the next highest score and so on. Here physics marks are 35, 23, 47, 17, 10, 43, 9, 6 and 28, right? So 47 is the highest mark. So you have to give rank 1. Second is 43. So you have to give rank 2 for 43. Third is 35. 35 is given rank 3. Then 28 is given rank 4. 23 is given rank 5. 17 is given rank 6. 10 is given rank 7. 9 is given rank 8. 6 is given rank 9. So physics are ranked like that. For mathematics score also you have to rank it. Mathematics score of same student who got 35 is 30. But the rank is 5. Second student got 33 marks in mathematics. So rank for mathematics is 3. Third student got 45 marks for mathematics and the rank is 2. Fourth student got 23 marks for mathematics. The rank is 6. Like that you have to give the rank for mathematics. Next, now we can go through the step 2. Add a third column D to your data. D is the difference between the rank. You look at the first student, physics rank is 3 and maths rank is 5. So the difference between 3 and 5, that is 2 points, right? So D you have to give 2. Look at the second student, physics rank is 5, maths rank is 3. So the difference is 2. Third student, physics rank is 1 and maths rank is 2. So the difference is 1. Fourth student, physics rank is 6, maths rank is 6. So the difference is 0. Okay, that is, so you have to give D for the difference in ranks. And the fourth column, please add D squared. That is a square of the difference. Difference is 2 means D squared will be 4. Difference is 1 means D squared will be 1. Difference is 0 means D squared will be 0. Now step 4. Add up all the D squared values. D squared values 4 plus 4 plus 1 plus 0 plus 1 plus 1 plus 1 plus 0 plus 0. We are adding up all the D squared values. You got 12. Okay. You will need this for the formula. What is the formula? Formula for Spearman correlation coefficient. Okay. Sigma D squared is the sum of D squared values. Okay. So insert the values in the formula. What is the formula? Formula for Spearman correlation coefficient is equal to, it is rho, R-H-O. That is a letter, it looks like P. So Spearman's correlation coefficient is equal to 1 minus 6 multiplied by sigma D squared. That is the sum of difference squared. Okay. Difference in rank squared. Okay. So 6 multiplied by sigma D squared divided by n multiplied by n squared minus 1. N is the total number of students. Here 9 students are there, right? So you have to fill in these values in the formula. Okay. So Spearman correlation coefficient is equal to 1 minus 6 multiplied by sigma D squared. That is 12 here. Divided by n. N is 9. Multiplied by n squared minus 1. N squared is 9 squared. That is 81. So you have to fill in those values here. 1 minus 72 divided by 720. So 1 minus 0.1. That is 0.9. That is a Spearman rank correlation coefficient for this set of data is 0.9. Okay. Now we can see how to calculate in SPSS. In SPSS, you have to follow this step: analyze, correlate, bivariate. Okay. There you select the two continuous variables, systolic blood pressure and body mass index. Two variables are selected. One of the two continuous variable is not normally distributed, or both of the continuous variable are not normally distributed. Then you have to choose Spearman correlation coefficient. Where to choose Spearman? You look at correlation coefficients. There are 3 options are there, right? So please choose Spearman correlation coefficient. Test of significance two-tailed and click OK. Then computer will give you the non-parametric Spearman correlation coefficient. So non-parametric correlation, Spearman correlation coefficient between systolic blood pressure and body mass index, Spearman correlation coefficient is 0.893. What it means? There is a strong positive correlation. Correlation coefficient can vary from -1 to +1. -1 means perfect negative correlation. +1 means perfect positive correlation. Here correlation coefficient is 0.893. What it means? It is perfect positive correlation or strong positive correlation. Significance value, look at the significance value, it is 0.000, it is less than 0.01. So it is statistically significant. Understood?